Okay, we have here today another integral. This one's from the Vienna integration bee 2024, problem 30. We have the integral of x plus 1/2 over square root x squared minus x plus 5/4 dx. Okay, this looks kind of messy, but it definitely also looks like the case where we can complete the square on this right here, factor this, and then maybe do like a trig substitution. So I want to just start with this right here. And if you look at this 1 right here, and we want to complete the square, we can take 1/2 of that, and so we can square x minus 1/2. If you multiply that out, you're going to have x squared minus x plus 1/4. Well, we have a plus 5/4 here, so in order to create that, if I just add a 1, then this is going to be the same as that. And then if I just rewrite this in this form, I think you can see then that it's in pretty good shape to do a trig substitution. Now there's a few different ways to deal with this right here. We can make a substitution here for tangent. We could do a use substitution first. It's an extra step, but like it kind of cleans it up and makes it a little easier to do the trig substitution. Or what I want to do is do a substitution for sinh here. It's kind of a trade-off, but this substitution is going to work pretty well in this case. So let's see how it goes. If we come over here and we need to, see it's a little messier because we can't just do like x. We're doing x minus 1/2 is going to be sinh of t. Take a derivative here, so we're going to end up with dx, because minus half's derivative, that's just going to be 0. Derivative here is going to be cosh t dt. And before we do the substitution, we can get a couple other values. Like first, here in the numerator, we've got x plus 1/2. Well, if you add 1 on this equation to get a value for x plus 1/2, add a 1 on the right side, this is just going to be sinh of t. And then also, we can take this equation, take the inverse sinh on both sides, just to get a value for t. And so t is going to be inverse sinh of x minus 1/2. So now we'll just substitute. We have this value here. So this is going to be sinh t. dx is going to be cosh t dt. Then here for all this stuff, this is going to transform into sinh squared t plus 1. But here we can use another identity. This here, this is the same thing as cosh squared of t inside the square root. Then we can just simplify this down to absolute value cosh of t. But the thing with that, cosh is always positive. So then we can just take this whole thing here and just cancel it with this cosh t in the numerator. So then all we have left to integrate is just this sinh of t here. Well, that's easy. The derivative of cosh is sinh. The derivative of sinh is cosh. So integrating sinh t, this is just going to be cosh of t. And then what do we do next? Well, of course, I made a pretty bad mistake. I forgot my plus 1 over here, right? We added 1 here, we added 1 here. So I forgot that. We have a plus 1 here. So then going back, we integrate sinh t, we get cosh t, integrate plus 1, we get a plus t. So now for this, we just need to back substitute. We already have our value for t, so we're all set there, but we don't quite have a value for cosh t. So let me make a little more space. If we can find this and back substitute, we can finish it off. Okay, so if we're finding our value for cosh t, what I'm going to do to start is we can use this identity that cosh squared of t minus sinh squared of t is just equal to 1. But actually what I want to do is just isolate the cosh, so we can rearrange this cosh t, squared t, adding the sinh squared t, this is going to become 1 plus sinh squared t. Take a square root on both sides just so that we're left with just this cosh t that we want. So now we have our value here, but we don't want this in terms of t. We want to get it back to x, but we have our value here for sinh in terms of x. So for this, it's going to be square root 1 plus this thing squared. So we're going to have x minus 1/2 squared. And then we know this t value, it's just going to be sinh inverse x minus 1/2 from right here. But this thing right here, this is the thing we actually found earlier when we completed the square. So we can put this back into this form the way we had it originally. And so for my final solution of this, we just have x squared minus x plus 5/4 plus inverse sinh of x minus 1/2, add a plus c, and that's it. Okay, there you have it. Good problem from Vienna 2024. Thanks everyone for watching. Have a good day.